Bismillahirrahmanirrahim. In this video we will see an example of mutually exclusive events and also when they are not mutually exclusive. So the example is that a jar contains 10 identical balls numbered 0 to 9. Randomly a ball is selected from the jar and we note down the number of the selected ball. So the first thing is that what is the probability of selecting a ball having odd number. So as we can see that the sample space consists of all the numbers of the balls from 0 to 9, and since there are only 10 balls and we have got numbers from 0 to 9 as well, so the probability of drawing each ball is 1 by 10. What the event is that what is the probability of selecting a ball having odd number. So we just look for all the odd numbers in this sample space, which is 1, 3, 5, 7 and 9. So this is our event. Our event A is comprised of odd numbers only. Since the balls are identical, the probability of selection for all the balls is equal. They are identical, and each ball, for example, there is only one ball of 0 number, there is only one ball of 1 number, so the probability is 1 by 10. Therefore, probability of event A is the sum of the probabilities of outcomes in the event. We simply take the sum of the probability of each event, each outcome, we add them and we will get the total probability. So as we said that the probability of 0 is 1 by 10 and the probability of 1 is also 1 by 10 because they are identical. The probability of having 1 or 3 or 5 or 7 is they have got the same probability. So we just simply add 1 by 10, 1 by 10, 1 by 10, and we get what we get is that 0.5. So the probability of having a ball having an odd number is 0.5, and it is quite intuitive as well because we know that there are 50%, 5 numbers are odd, 5 numbers are even out of 10, so the probability is 50%. What is the probability of selecting a ball which is a multiple of 3? So here the event is the number is multiple of 3. From the sample space we can see there are only 3 such numbers, that is 3 itself, 6 and 9. So the sample space is B is equal to 3, 6 and 9. The probability of each outcome is 1 by 10 and we add them up and what we get is 0.3. What is the probability of selecting a ball which is odd and multiple of 3 as well? So here the events are not mutually exclusive. If the selected ball is 3, then it's odd and multiple of 3 as well. It means the events A and B are not necessarily mutually exclusive. Hence, probability P union probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Probability of A intersection B is simply the addition of the probabilities of the outcomes common in both event A and event B. So we know that event A is 1, 3, 5, 7 and 9 and event B is 3, 6 and 9, and the common outcome in these two events is 3 and 9. Therefore only two outcomes are common, 3 and 9. Therefore probability of A intersection B is equal to probability of 3 plus probability of 9, which is equal to 0.2. So probability of A union B is equal to 0.5 plus 0.3. This 0.5 is probability of A, 0.3 is probability of B, and 0.2 is the probability of P intersection B. So the total outcome is 0.6. What is the probability of selecting a ball having number less than 5? So number is less than 5, it means all the outcomes are 0, 1, 2, 3 and 4 up to. It does not include 5, it is less than 5. So the probability of each one is 1 by 10, just adding them up, and again we get the probability is equal to 0.5. What is the probability of selecting a ball which is odd, multiple of 3 and less than 5? So events A, B and C are not mutually exclusive. Why? Because the probability of selecting a ball is odd and multiple of 3 is an odd number, so it both can if you select 3, then it will be odd number, and 3 is also less than 5. So these events are not mutually exclusive. So if you select 3, it means it will be odd, it will be multiple of 3 and it will be less than 5. In that case, the probability A union B union C, as we have seen this formula before, probability of A and B and C and intersection of AB, intersection of AC, intersection of B and C and intersection of ABC. We already know this P of A, P of B, P of C, and probability of A intersection B we have already calculated over here, which is 0.2, and probability of A intersection C is probability of 1 and probability of 3, because we can see that the common number in this set 0, 1, 2, 3, 4 and A over here 1, 3, 5, 7, only two numbers or two outcomes are common, 1 and 3. So in that case we will just simply take the probability of 1 plus probability of 3, which is also 0.2, and intersection of B and C is only 3, because 3 is the only common outcome between events B and C. In that case the probability is 0.1, and probability of A intersection B intersection C is also 0.1, because it is again the common element between these three events is 3, common outcome is 3. So probability of A union B union C is just plugging in these values in this formula, and what we get is 0.9. What is the probability of selecting a ball having even number? So it is very simple, and it is very much similar to the last one here, first one, where we say what is the probability of having odd number. We have just replaced these odd numbers with even numbers, and of course there are 5 even numbers, so we again get the same result, 0.5. And then we have what is the probability of selecting a ball which is not a multiple of 3. So all the numbers which are not multiple of 3, which is of course other than 3, 6 and 9, is 0, 1, 2, 4, 5, 7 and 8, and we again just add up all the probabilities of each outcome, and the final result is 0.7. We could have achieved this result also by just subtracting it from 1.